Hello everyone, let's start talking about some terminal points. We're going to introduce some unit circle concepts. So the first thing that we're going to talk about is when I say a unit circle, what I mean is a circle whose radius is 1 unit. So this, you can see if you zoom in a little closely here, it's got labeled right there 1 comma 0. That means that the radius of that circle is 1. And what we're doing is we're saying, look, there is a point on this circle and it's right here in the first quadrant. And you can imagine drawing a triangle here where you have an x-coordinate, which is 2/7, and you don't know the y-coordinate, that's what we're trying to find, but we know the hypotenuse is 1. So if you're trying to find a missing side on the unit circle, you're just going to do Pythagorean theorem. You're going to say the x squared plus the y squared is 1 squared. And just as a reminder, this is true for any point on the circle. You have an x-coordinate, you have a y-coordinate, and if the radius is 1, this is the equation for a circle with radius 1. So we're just using Pythagorean theorem here on this triangle. When you square fractions, you multiply the top and the bottom. So 2 squared is 4, and 7 squared is 49, and 1 squared is just 1. Now, remember, if you're going to add or subtract fractions, you need to have a common denominator. If I want to do 1 minus 4 over 49, that's 49 49ths. So if I subtract 4, I have 45 49ths. And now I'll square root both sides, and I'll say this is the square root of 45 over the square root of 49 is 7. And we're just going to leave it like that for now. So radical 45 over 7 is the missing y-coordinate. Let's try another one. Now, they tell you that the y-coordinate is negative, and they're drawing it over here in the third quadrant, which hopefully you realize the x-coordinate is also negative. I know that the y-coordinate is negative radical 15 over 4, but I don't know the x-coordinate. So I'm going to find the x-coordinate by using Pythagorean theorem, knowing that the radius is again 1. So I'll do x squared plus negative radical 15 over 4 squared equals 1 squared. And just as a reminder, the fact that it's negative isn't going to matter because a negative times a negative is still a positive. X squared plus, when you square radical 15 times radical 15 is radical 225, which is just 15. You just get the radicand. So this is 15, and then 4 squared is 16. But again, if you know you're going to subtract 15 sixteenths from one whole is 16 sixteenths. So now if I do 16 minus 15, I get 1 16th, and I will square root that. And now we get x equals 1/4. But what we need to be aware of is when you square root both sides, it's really plus or minus, but specifically in this problem, since I'm in the third quadrant, x is to the left of the y-axis, I know it's actually not plus or minus, it's just negative 1/4. This is negative 1/4 because I'm in the third quadrant. Okay, so that's one of the concepts that we need. The other one is talking about terminal points, and we're going to have to do a little bit of a rundown here. When you are plotting terminal points, you start off with 0 degrees at the top, or 0 degrees to the right rather, 90 degrees is straight up, 180 is to the left, and 270 is down. That means if you keep going, this is also 360. Those are called coterminal angles, 0 and 360. I could keep doing this, adding 90 over and over again. But when I talk about reference angles, what we're going to do is say, okay, if this is 0, this is 90, and this is 180, and I'm trying to graph 240, I got to keep going. I'll just leave it up there. 270 and 360, that's 360. 240 is between 180 and 270. It's down here somewhere. What I want you to be able to do is tell me how many degrees past this 180 did we rotate to get to 240? And that would be 60 degrees. So the reference angle is 60 degrees. That's the one formed with the x-axis. We're always going to draw a triangle to the x-axis, draw an altitude. If I do the same thing with 100, you're like, okay, this is 0, that's 90. I got to go 10 degrees more, but I don't really care that that's 10 because I'm dropping this to the x-axis. So how far away from 180 is 100 degrees? That would be 80 degrees. So the reference angle here is 80 degrees. I'm going to do more of those, and this is a really important concept for the unit circle. So let's do a bunch of them. 0, 90, 180, 270. I got to go a little bit more, 300. But you always want to compare it to the x-axis So if this is 360 and I'm at 300, that's 300, then I'm 60 degrees short. That's the reference angle. 0, 90, got to keep going. That's 180. I didn't quite make it to 180. So if this is 180 and I'm at 150, that means I'm 30 degrees short. The reference angle is 30 degrees. Now, if it says 180, you're like, right there. That's it. Okay, there is no reference angle. You can say it's 0 degrees, but we will have problems that are on the x and y axis, and they are always tricky. What if the angle's negative? So normally we rotate counterclockwise or anti-clockwise, but if it's a negative angle, we rotate actually clockwise. So we say 0, and then we go 90, and then I got to go a little bit more. But again, this would be negative 180, so I'm 80 degrees short of the x-axis. If I kept rotating 80 degrees more, that angle right there is negative 100, what I just measured. 110, 0, 90, I got to go about 20 degrees more. But again, you're not comparing this 20 degrees. I don't really care about that. It's 70 degrees formed with the x-axis. Okay, so there's 110, and then there's 70 degrees more to make 180. Negative 350. Negative 360 would be all the way around, but I don't quite make it around. Okay, I only made it this far around. That's 350 degrees. So then the reference angle would be 10 degrees. If I went 10 degrees more, I would be all the way around. Okay. Now, the last thing is we're going to just draw right triangles and analyze them. So this says given that the sine is 5 over 13, the sine of an angle, I'm going to draw a triangle where that's true. I'm going to draw a triangle where the sine of theta, so I'll just call this theta, is 5 over 13. That means opposite over hypotenuse is 5 over 13. Now, if you know two sides of a triangle, you can always find the missing side. A squared plus b squared has to be c squared. So 5 squared plus, I don't know this, I'll just call it x squared, is 13 squared. This is a Pythagorean triple you should probably just memorize. Square root of 144 is 12. Okay. Now, it doesn't tell us anything about what quadrant we're in, so I can't really determine that. But what I can do is now go through all 6 trig functions and say, okay, the sine of theta. Do I know the sine? Yeah, it's 5 over 13. I gave you that one. Hope you get that one right. The cosine of theta is adjacent over hypotenuse, so 12 over 13. The tangent of theta is opposite over adjacent, so 5 over 12. Now, to get these, you just flip them. The most important thing you remember is that secant and cosecant are reciprocals. So 5 over 13 becomes 13 over 5. Secant is 13 over 12. Cotangent and tangent are reciprocals. That's 12 over 5. Okay. I didn't tell you what quadrant we're in, so there's not a lot you can do. But in the last one we do, I say quadrant 2. So I'm going to draw this in quadrant 2. I'm going to draw a triangle. And I'll call my reference angle theta, and I'll say that opposite over adjacent is 4/3, but notice how it's negative. Why is it negative? Or maybe I should ask, is x or negative, or x or y negative in this quadrant? If you're in the second quadrant, well, y is positive, but x is negative, so that's negative 3. That's why this whole fraction comes out to be negative 3/4, or negative 4/3 rather. Now I'm going to do Pythagorean theorem, 3 squared, plus 4 squared is the radius squared. So we don't know that we're on the unit circle in this problem. So 9 plus 16 is r squared. That's 25. And when you square root 25, you get 5. So the radius is 5. And that is always positive. The magnitude, the radius, is always positive. The reason x and y are negative is because we're talking about relation to the origin. We went to the left. So we got to say, oh, okay, if you go left, x is negative. If you go up, y is positive. But the radius is always a positive number. So now that I have my triangle drawn, I can start to list them all. Sine of theta. Let's do the main 3 first. So sine of theta, opposite over hypotenuse is 4/5. Cosine of theta, adjacent over hypotenuse, is negative 3/5. And tangent is opposite over adjacent. Oh, that's what I gave you, 4 over negative 3. Now, it doesn't matter if you put the minus sign in the top or the bottom or out front, the fraction is negative if there's a negative in any of those places. If you put it twice, now it's not negative anymore, so don't do that. Now I'll just flip them. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and since this is negative, this will stay negative. And then cotangent is the reciprocal of tangent, so this will be negative 3/4. Okay. These are some pretty heavy-hitting unit circle concepts that we need to be very good at. So if you need to, watch this one again. And if you haven't already, smash that like and subscribe.